Okay, so let's get started. We're going to be taking a look at how to set up and work with our PID-based tuning for our drive-by-wire throttle control. The last training module, we went through some of the basic configuration and setting details to get our accel pedal position and our throttle position sensors calibrated for our drive-by-wire throttle circuits. We're going to expand on that in this training module and learn how to complete the rest of that calibration process. Now, the good news is we can actually do all of the drive-by-wire PID-based tuning without the engine running. So we can sort this out and then fire up the engine and everything will work properly as we're expecting with drive-by-wire control. So we don't actually have to drive the vehicle and do a lot of testing there. We can do all this key on, engine off. All right, so let's take a look right now at the setup and configuration details for our drive-by-wire, where we're at. We'll talk about a couple details, and then we're just going to go through a demonstration of setting up our PID gains and our feed-forward table, and then see what the results are going to look like so that we know that the system is actually calibrated correctly and that we can expect proper results and consistent and predictable results when we're actually trying to run our engine with the drive-by-wire circuit. So let's move here from our fuel page and let's jump across the drive-by-wire. That's where we found ourselves in the last training module. And we're going to go here to our E-Throttle 1 setup. I'm going to go through some of the details here in this window. We don't need to touch anything further in our throttle position or accel pedal position windows. This has already been calibrated and set up for us beforehand, so we don't need to go through any of that. So let's take a look here at some of our settings. So our E-Throttle mode, we want it in our setup mode. The setup mode allows us to do this testing procedure that we're going to find in this training module. If you have it set to on, that can create some problems for us. Once we have calibrated the system, we can turn it to on so it has the fail-safe tracking in place. That is important long-term, but short-term right now to get this thing going and making sure that it's calibrated correctly, we're going to make sure that we're just leaving it on our setup mode. Then our output's been defined for the half bridge control, which is a full bridge output between the two half bridge. For aux 9 and 10, you define that wherever it's going to be. The active state is typically going to be low for most drive-by-wire circuits. We can do low or high, but low is what I have here for the Hitachi 350Z throttle body. E-throttle relay is set to internal for a G5. If you're working with a G4X, you'll have to assign it to an aux output to control an external relay to cut the power supply off if there's a fault in the system, so that the throttle shuts and it goes back to the neutral spring return, the return level of that throttle blade opening. Every drive-by-wire throttle is going to have that. We can see right now, since we've calibrated our throttle position sensor, or sensors, I should say, in the drive-by-wire throttle body, we're going to find with no output control to the drive-by-wire throttle body that the TPS main and subs are parked at 5%. That's where the neutral return spring is placing the throttle blade as it's not energized through the control from the link. So this is important because we actually have to work with this in our feed-forward table, and we're going to talk about that. So internal is what we use for G5. Auxiliary aux output is going to be used for G4X to control that relay, to use that for the fail-safe shutdown. With the G5, it does that all internally. The actual internal, the relay is internal to the board. The frequency here, it's usually between 500 to 1,000 hertz. Now, this can depend on what type of throttle body you're working with. One thing I want to show you real quick, if you're unfamiliar with getting some of the settings here, so you don't know what frequency to use, I would probably start off with 1,000 for most every throttle body, but Link actually provides some guidance and some values to start off with for the frequency as well as the PID gains, depending on the throttle body you're dealing with. So they've documented a couple popular throttle bodies. Let's take a look at that real quick. If we go to our help menu to the contents, and then if we type in here specific E-throttle in the search function and click list topics, you'll actually find here your second choice, specific E-throttle applications. If we double click, we can find here that we can click on these defined options in our help menu, and it tells us a lot of these settings. This will help you set up things very quickly. So for example here, I actually use a lot of Bosch throttle bodies because they're inexpensive and they're very, very reliable. The 82mm throttle body is used on Porsche GT3s and Lamborghinis, so obviously it's reliable and it works very well, and it's relatively inexpensive. You can get them about 150 bucks. So I use the Bosch throttle bodies frequently. So this is going to actually tell us a lot of important information. This is going to tell us the pinout on the actual throttle body itself. It shows us where we can expect to find the positive and negative control for the wire, sensor ground supply, and the signals. So that's really important details. But more importantly here, if we go down a little bit, we're going to find that we have some more details such as the pulse width modulated frequency, the proportional, integral, and derivative gains, which we're going to talk about here in just a little bit. We can find all of that information documented right here. This is going to save you a lot of setup and configuration time. Now, we'll still check things once we put their default values into the software, but this is going to be a solid starting point. If we use our back arrow here, we can get back to some more details. If we look at our Nissan VQ35, that's exactly what I have for my throttle body. Unfortunately, in here, it does not define the frequency or the PID gains to run our throttle body at. So we're gonna learn how we can actually sort this out if we don't have the PID gains or the frequency. If we go here to the back button, we can find other popular throttle bodies. Here's a GM throttle body, so an LS3 throttle body. We can see here that the frequency, deadband, proportional, integral, derivative gains, and min and max clamps are all defined in this window here. So it tells you that information, plus it tells you also the wiring pinouts here, what the servo motor negative and positive are going to be, the sub main and the TPS sub and main here. Very important details. So I just wanted to point this out in case you're looking for some specific information. It's going to be found in that menu right here in the drop downs that we can go click on and see more details. So let's go ahead and close this real quick. So unfortunately, we're heading into this tutorial without knowing a specific frequency we should run the throttle body at and specific PID gains. Now, these PID gains are the default ones that popped up when we started to turn the feature on. They're actually pretty close to what I would start off with. So we're actually going to test with these PID gains and see how well it controls. Now, the min and max clamp, I typically set it at plus or minus 90 as a starting point, and then we can start to trim down our min and max clamp based on what we're actually seeing for the output motor control. And then we also have here our Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.